Okay, so now we're going to take the same example that we saw pictorially in the previous video and prove the results that we determined from the images. So we've got the same function, f of x is 9 minus x squared, that downward opening parabola. We need to show that this f of the image of the interval from 1 to 4 is the interval from -7 to 8. Well, remember what it requires to show that one set is equal to another set. We have to show that this left-hand side is a subset of the right-hand side, and the right-hand side is a subset of the left-hand side. So this is kind of my two cases. I've started them already. The first one is show the left is a subset of the right, over there, and then show that the right is a subset of the left. So let's proceed. I'm going to let B be in order to show that this is a subset, I have to arbitrarily choose an element from here and show that it's also in here. So I'm going to let B be the element in f of the interval from 1 to 4 to show that B is also in this set. Okay, well, what does that mean for B to be in this set? By definition of what this set image is, if B is in this set, there is an A in 1 to 4 that maps to B. There exists an A such that f of A equals B. All right, so I want to use all of my space here. In other words, I'll put or. What is f of A? F of A is 9 minus a squared, where B equals 9 minus a squared. That's what it means for f of A to equal B. Okay, let's solve that for A. Solving for A gives the following. Maybe I'll let you do the algebra. Let's see. I'm going to kind of do it in my head because I don't have too much room here. I'm going to add I'm going to add a squared to both sides to get it over here in a positive form. Subtract a b. So that would give me a squared equals 9 minus b. And then simplifying one more time, using the square root property, I get a equals plus or minus radical 9 minus b. Okay. Thus, if this is true, if a is equal to that, well, a is in between 1 and 4, right? It's a number in the closed interval from 1 to 4. So I could say 1 is less than or equal to plus or minus radical 9 minus b, which is less than 4, because that's just a in the middle. We'll notice that the negative version of that is impossible. So our a must be the positive version of that, because a radical is a positive square root, a positive number. So clearly a negative number is not between 1 and 4. But regardless, we're just going to square all three sections. And by squaring all three sections, we get 1, square that, square this, we're going to get 9 minus b. Square this, we get 16. So what we did from this step to this step is simply square all three sections. Okay, so let's get b in the middle now. B by itself. So if let's see, I think I'll first get rid of the 9. Subtract 9 from everything. Subtract 9 here, here, and here. And that'll give us negative b by itself. So I'd get a negative 8, less than or equal to negative b. Less than or equal to 16 minus 9 is 7. If we multiply by negative 1, what do we get? if we multiply by -1, remember we have to reverse all of the inequalities when we do that. So b will still be in the middle. And this becomes a positive. I'm having to put it over here now. Now maybe I won't skip any steps. It would be an 8 greater equal b greater equal -7. Now I'll write it as -7, 8, and we're done. Remember what we did? We had to show that b is in the interval from -7 to 8. So implies b is in the interval from -7 to 8. That's the proof of the first case, of one direction proof. Now let's go the other direction. We're going to take an element in -7 to 8, and we're going to prove that it's an f of the interval from 1 to 4. So let's, as above, let's let b be an element in this, and we'll prove that b is in this, to show that b is in that. And what does that mean? What are we going to show? That is, we need to show that there is an a in 1 to 4, such that f of a equals b. Okay, and remember what f of a equals b means. This. So I'm going to put, as above, a is equal to, it's exactly the same algebra, plus or minus 9 minus b. It's one of those. We're going to choose, because we know the -1 failed. The -1 puts a outside of this interval. We're going to say, we're going to choose a equal 9 minus b. All right, so now what do we get? That means that radical 9 minus a, 9 minus b, excuse me. Let me just put the period there. What value does b have? It's between -7 and 8. Let me write that down. Okay, well, I would like something like, I would like to get this in between two numbers. I would like to do some algebra and get, instead of b in the middle, I would like to get this in the middle, radical 9 minus b. Okay, so that means I need a minus b. Now that implies, let's see, if I get a negative b, I need to multiply this whole thing by a -1. So that's going to give me a negative b in the middle. If I multiply it by a -1, I get 7 greater equal b greater equal -8. Which, if I flip it all the way around, I get that. So convince yourselves that when you multiply that triple inequality, or double inequality, by -1, you end up getting this. So the 8 became -8, this -7 became 7, and b became a negative b. Now let's add 9 to everything. That'll give me a 9 minus b. So that's 1 lesser equal 9 minus b. Lesser equal, let's see, I subtracted 9, or I added 9, so that's going to become 16. And what happens if we take the square root? If this inequality holds, if I take all 3 square roots, it's also going to hold. So that implies 1 lesser equal radical 9 minus b lesser equal 4. And that means this is a. 1 is less than or equal to a, it's less than or equal to 4. And that's what we wanted to prove. To show there is an a, so we selected the a and we proved that it's a number in between 1 and 4. So I'll go ahead and say A is in 1 to 4. And that is the end of that proof.